All right, so yesterday you did the convergent part of your notes, just this flap. This is the only flap you should have done. Today you are completing the next two flaps of your notes. If you did not do this first part yesterday, you need to go back and do yesterday's assignment first. Today you will submit a picture of your notes to get credit for your notes. So to get a 100 as long as you did your notes. So go back if you didn't do yesterday's. But today we're talking about divergent and transform boundaries. So remember, yesterday was about convergent collide. The plates come together, they collide, they converge. We either have subduction or uplifting, one of the two. Today, the first one we're going to talk about is called divergent. Divergent divide. So divergent, they're spreading apart. And it depends on what type of crust we have. Depends whether we are looking at continental crust, which is land crust, or oceanic crust. So in the first one, we're looking at continental crust. So two plates on land that are spreading apart or diverging. We see this happen in Iceland. Iceland has a boundary that cuts straight through it, and the two plates are separating. So technically, Iceland is getting bigger every year. Anyways, it forms what is called a rift valley. You probably have heard of a valley. You probably haven't heard of a rift valley. A valley, is a dip, a curved dip. But a rift valley, notice it's not smooth, it's not curved. Think rift like jagged, rough. So sometimes I think of it as a rough valley. It has these rough edges, and that's just because of the way the plate is pulling apart. The plates are pulling apart. Sometimes they fill with water because it's a low standing area. So you may see water in a rift valley, but it doesn't have to have water. It's not in the ocean. If we have two oceanic plates diverging, spreading apart, it's unique what happens here because they're spreading apart and magma comes up from the mantle. Magma comes up in the ocean, and as soon as magma hits the water, it hardens and turns to rock. So we get little ridges, and over time, these are not little, I call them little ridges, but over time, these form like mountains in the ocean. Remember, this is what Harry Hess discovered. Alfred Wegener almost proved continental drift, but he was missing this piece of evidence. And Harry Hess proved seafloor spreading, which is the same thing as the plates diverging or separating. He proved it because he took a measurement of the age of this crust right here in the center. And the crust was really young. Why would it be young? It's brand new because it's new magma that's come up and hardened. But the crust over here on the edges was old. And the crust got older as you moved outside. So that proves that the plates are spreading apart. So anyways, this makes a ridge. Every year I say, it's kind of gross, but I say it's kind of like a scab. Because when you have a cut in your skin pulls apart. And what comes up to fill that? Blood comes up to fill that. It hardens and it forms a scab. So it is really similar. And it kind of looks like a scab on the Earth's crust. In your Nearpod, you're going to see what would happen if all the water was removed from the Earth. And you can see the ridge. There's something called the Mid-Atlantic Ridge. It goes from so far south, almost Antarctica, all the way up north. And it looks like a big scab across our Earth. So underneath the flap, just a little writing today. We have our land features for continental. Continental is a rift valley. And our land features for oceanic. Oceanic is an ocean ridge. So when I say, remember, divergent is your two R's. A divergent boundary makes rifts or ridges, your two R's, rifts or ridges. Okay, the last one is a transform boundary. Most of y'all know about this type of boundary. It happens in California a lot. So a transform boundary is when the two plates are rubbing up against each other. Over time, the friction builds up. They don't not just chilling, just sliding. I say slip and slide, but they're not just slipping and sliding everywhere all the time. They build up a lot of pressure because they're trying to get past each other. That's released in the form of an earthquake. After an earthquake, there's a crack in the crust. If you've seen the movie San Andreas Fault, San Andreas, there is a crack in the crust called San Andreas Fault. You can drive there in California and see that. You can go on Google Earth and you can see San Andreas Fault. So at a transform boundary, we get an earthquake and we get a crack in the crust called a fault or a fault line. Really, these are not two separate things. We have an earthquake, and a fault is the result of an earthquake. You can't get a fault without having an earthquake. So these are our three boundaries. Convergent ear plates are colliding. You could get subduction or uplift. Divergent ear plates are dividing. Transform ear plates are slipping and sliding past each other. And for divergent and convergent, it's important that you know what type of crust you're talking about. Transform boundaries, the same thing happens whether it's on land or in the ocean. There are earthquakes in the ocean. There are faults in the ocean. So I hope you enjoy your Nearpod and your field trips that are in your Nearpod, which is the VR things. I would suggest you try doing them on like your phone or an iPad if you have one, because the VR things look really cool on your phones or your iPads. If you log out of Nearpod and log back in, you don't have to start over. You can go back to where you were. I know where you were in Nearpod. Don't worry about it. And don't forget to submit your picture of these notes. It is a grade. Don't forget to submit your picture of these notes. Doo-doo.